Welcome back to my YouTube channel. Today I'm talking about the runif function in R. The runif function generates random values from the uniform distribution. The only required argument is n, the number of values you want to generate. Minimum and max are optional arguments. If you do not specify them, the default is 0 and 1. So you'd have a uniform distribution going from 0 to 1, which is a common way to think about the uniform distribution. Okay, so I'm going to go ahead and get started. I'm actually going to go ahead and start off big and do 1 million samples from the uniform distribution. So we have, I'm going to go ahead and do about 20. So the first 20. And you see we get a whole bunch of continuous values from 0 to 1. If I do the mean of this, I get a plus b divided by 2. So 1 plus 0 divided by 2. Or if we actually want to use both tails, I can do I'll make the minimum 5 and the maximum 10, so the mean to be 7.5, and the mean 7.5. The variance is b minus a squared divided by 12. I think I might actually go ahead and use that same distribution with both tails. It's 1 minus 0 is not the most illustrative. So 5 to 10. Okay, so let's do that calculation real quick to make sure what we got made sense. So we got b, so that b is the maximum value, minus a, which is the minimum, carry 2, and divide that by 12. And we got a matching value. Normally I like to do a simulation where we get the proportion of values between two points, like the proportion between 0.4 and 0.6. This is obviously going to be 0.2 here, because everything is equally likely. But I'm still going to do it. That's for the sake of completeness. I've done it everywhere else. And I think it's a good thing to think about and be exposed to. So I set my counter equal to 0, because I'm going to be counting up. So I made a counter variable. So for I in 1 to the length of x, the length of the x vector is 1 million. So it's saying for I in 1 to 1 million, make parentheses. I want a if statement. So if x of I is greater than 0.4 and x of I is less than 0.6, another set of brackets, and then counter equal counter plus 1. And when we do that, we get a value really close to 0.2. Of course, it's never going to be approximate if we're doing this by simulation. What about you? Yeah. Lost my track. Okay. So we got a value really close to 0.2. That's as we expect. Get everything to equally probable. And that's 0.2. Okay. So that's the end of the video. Thank you for watching.